NASA recently confirmed the detection of organic molecules on Mars. But instead of celebration, this discovery has raised serious questions. For decades, scientists have searched Mars for signs that it may once have supported life. Water, minerals, and geological features have all pointed toward a more active past. But organic molecules represent something different. They are not proof of life, but they are essential ingredients. Organic molecules are the building blocks of life as we know it. They are carbon-based compounds that form the foundation of biology on Earth. Every living organism, from the simplest bacteria to complex humans, depends on organic chemistry. Carbon is unique because it can form long, stable chains. These chains allow molecules to become increasingly complex, enabling chemical reactions that support life. On Earth, organic molecules are closely linked to biology, but that connection can be misleading. Organic molecules do not automatically mean life. They can also form through natural, non-biological processes. In space, organic compounds have been found inside meteorites, on asteroids, and within interstellar clouds. Chemical reactions driven by heat, pressure, radiation, and minerals can create organic molecules without any living organisms involved. This is why the discovery on Mars is both exciting and confusing. What makes this detection unusual is not just what was found, but where it was found. NASA's Perseverance rover detected organic molecules inside ancient Martian rocks. These rocks are located in a region that once contained liquid water billions of years ago. Geological evidence suggests that this area may have been part of a lake or river system during Mars's early history. At that time, Mars looked very different from the cold, dry world we see today. Its climate was more stable. Its atmosphere was thicker. Liquid water flowed across its surface. Because water is essential for chemical reactions, these environments are considered some of the most promising places to search for the chemical origins of life. However, these rocks have also been exposed to intense radiation for an extremely long time. Mars lost much of its magnetic field early in its history. Without that protective shield, the planet became vulnerable to cosmic radiation and solar particles. Unlike Earth, Mars has a thin atmosphere that provides very little protection. Over billions of years, radiation constantly bombarded the surface. Under normal conditions, such exposure should break apart complex organic molecules. Radiation destroys chemical bonds, slowly degrading organic compounds into simpler elements. This is why scientists expected organic molecules on Mars to be rare, fragile, and short-lived. But these molecules did not disappear. Despite the harsh environment, some of the detected compounds appear more complex than scientists expected. They show signs of having survived for an extraordinarily long time. This raises an important question. How did these organic molecules survive conditions that should have destroyed them? Scientists are now trying to understand the mechanisms that could explain this survival. One possibility is that Mars once had a more stable environment than we previously believed. If conditions remained favorable for longer periods, organic chemistry may have progressed further before the planet became hostile. Another idea focuses on protection. Organic molecules may have been shielded inside rock formations. Certain minerals can trap organic compounds within their structures, protecting them from radiation and extreme temperatures. There is also growing interest in underground chemical processes. Below the surface, Mars may still host slow chemical reactions driven by heat, pressure, and mineral interactions. These reactions could help preserve organic molecules, or even continuously replenish them over time. None of these explanations require life to be present. But they do suggest that Mars has a more complex chemical system than previously assumed. It is important to be clear about what this discovery does not mean. This finding does not prove that life ever existed on Mars. There is no direct evidence of biological activity. No cells, no fossils, no unmistakable biosignatures. NASA scientists are deliberately cautious with their language. They distinguish between chemical ingredients and biological proof. This distinction protects scientific integrity and prevents misleading conclusions. However, the discovery does confirm something critical. Mars once had the right ingredients for life: water, energy, and now, confirmed organic molecules. Even more importantly, some of these ingredients may still exist today, preserved beneath the surface. Each new discovery like this influences how future missions are designed. It affects where rovers drill, what samples are collected, and which regions are prioritized for exploration. The ultimate goal is sample return. NASA plans to bring carefully selected Martian rocks back to Earth, where they can be analyzed with instruments far more advanced than anything that can be sent to Mars. These samples may help answer questions that rovers cannot. They may reveal how organic chemistry evolved on another planet, and whether Mars followed a path similar to Earth, or a very different one. Mars is no longer seen as just a cold, dead planet. It is now understood as a world with a deep and complex chemical history. A planet that once had the conditions necessary for life. A planet that may still preserve the chemical traces of that ancient past. And this signal from Mars may be just the beginning.